We are going to use something called the tabular method or the box method to help us multiply polynomials. Before we do that, though, it helps us to have a good understanding of how this works with just normal numbers so that we can apply it to more difficult problems. So let's just start with 28 times 27, which we know if we just plug into our calculator is 756. So starting here, we're going to target 756 to prove out that this method works. So I'm actually going to kind of go in reverse here to start. And I'm going to rewrite 28 as a binomial of 20 plus 8 and 20 plus 7. Now that I have that split into two separate binomials, I can use what we call the tabular method or the box method to actually calculate this out. And some of you might recognize what this looks like from elementary school or middle school. I can throw the first polynomial, this 20 plus 8. I can throw that on top. And I can throw the 20 and 7 on the side. Now, to get the values in the box, we multiply our columns times our rows. So this top left box here, we get 20 times 20, which gives us 400. The top right, we have 8 times 20, which gives us 160. Bottom left, we get 20 times 7, which is 140. And the bottom right, we get 8 times 7, which is 56. Now, we have all of the boxes filled out for multiplying, and we're going to add up all these boxes to get our final answer. And if you plug this into your calculator and you go 400 plus 160 plus 140 plus 56, you will surely get 756, which matches what we have up top here, right? So the purpose here is simply to prove out that this method works. We're going to expand this to polynomials and make it a little more complicated. So if you go to the next section of your notes, we can formalize the steps here and reference these back during a quiz or an exam. So the first thing we do is draw out a table, place our polynomials at the top and the right of that table. Then we multiply the terms on the outside to fill in each box. Then the third step is a little more tricky with polynomials. We combine like terms because we can't possibly add them all together. And then we're going to rewrite our final answer so it's nice and clear. Pause this video, make sure we have these steps down on our notes. Now that we have these steps down, let's go through an example problem. So we have x plus 8 times x plus 7. Right? There's two terms in the first polynomial and two terms in the second. So we're going to use a 2 by 2 box just like we did with our number problem. And we're going to put x and 8 up top and x and 7 on the side. We multiply into the boxes, so we get x times x gives us x squared, then 8x, then 7x, and finally 8 times 7 is 56. Now we're on step 3 of our process, and this is where we're adding all of these terms together. But you'll notice that one of them ends in x squared, two of them end in x, and one of them ends in 56, so we can't smush this into one term. We need to combine like terms. And the cool part about the tabular method is if we use these diagonal lines here and trace diagonally through our box, we're going to highlight all of our like terms that we can combine. So that first one is just x squared. That's the only term that we had there. This next one, we have 8x plus 7x, which gives us 15x. And this final one, 56, is all alone. And this gives us our final answer here, okay? X squared plus 15x plus 56. Let's do one more example as a group here. And actually this one, I want you to try for yourself, pause the video, and then check and see if you got that correct. And I'll give you a hint. We're going to use a 3 by 2 box for this, and it's based on that first polynomial having 3 terms and that second polynomial having 2. So go ahead, try this yourself real quick, pause the video, and then come back and we'll explain. All right, just like before, our first polynomial goes up top. We'll get x squared, 3x, and -1. Make sure that negative keeps through the entire problem. And then the x2 goes on the right side, x and 2. Then we just multiply into the boxes again. We'll get x to the third. We'll get 3x squared, -1x. Then we're now multiplying in our second row, so we multiply with the 2. We get 2x squared, 6x, and -2. Then we're going to add like terms, combine like terms. We can use those diagonal lines to help us. Okay, x to the third is all alone. 3x squared plus 2x squared leaves us with 5x squareds. -1x plus 6x leaves us with 5x. And finally, we get -2 at the end. And this is our final answer. Let's just rewrite it nice and clean. X to the third plus 5x squared plus 5x minus 2.